All right, so again, happy Wednesday, happy hump day, right? Middle of the week. So you had two questions, right? You had two questions. And so the first one was, nope. There we go. First one was this one. And all I wanted to know, what do you notice? What do you wonder? That's it. Look at this. Tell me what you notice. Tell me what you wonder. And let's see what you guys said. Now, this is what I mean by being specific, okay? So I had this problem with the 11th period. I had a lot of people saying, I noticed there's two triangles. I noticed they have numbers. I noticed they have letters at the corners. Okay, we're not in that. Okay, that is all true. That is all true and not wrong. But we're in high school. We're in 10th grade, right? That's something I expect to hear from a elementary school kid. Okay, what I want from a 10th grade high school student is I want more specific. What do you notice about the numbers? Don't just tell me there's numbers. What do you notice? You got to be specific. It's like if let's say we're in school, and I know we haven't been to school in a year, but you're in school, and then you go up to an adult and say, oh, that kid over there is bothering me. And then the AP goes, or the adult says, okay, which kid is bothering you? That one over there. There's a lot of people over there. Can you describe the person that's bothering you? And then you say, oh, yeah, the one with the hair. Okay. Can you be a little more specific? Yeah. They have hair. They have two eyes. They have a nose. And they have two ears right there. And they're standing up. They're wearing clothes. And they're wearing shoes. Can you be more specific? Oh, I'm sorry. They have two hands. They have 10 fingers. They have 10 fingers right over there. See, that's the kind of stuff that is not specific enough, right? So if that's not the kind of answers I'm looking for, be a little more specific about what you're noticing. And then if you don't notice, be as specific as you can. And if there's something that you can see, but you're not exactly sure, then that's some of the things that you wonder, right? Then you can say, well, I wonder why, or I wonder how these numbers are related, because I see that there's three numbers here and three numbers, that kind of stuff. So let's see if you did better than, if you did better than first period. Okay, let this load. There we go. So let's see. For this first picture, I noticed that the images are the same triangle, but the right one was shrunk. Okay, so that's good. So this person's saying that these triangles are exactly the same, but this is just a tiny version of it. It shrunk. I also noticed that the numbers on the side of the triangle have changed when made smaller. I wonder if those numbers are the measurements. Yes, those numbers are the measurements, right? The measurements of the side. That's 30, that's 20, that's 25, that's 15, that's 12, that's 18. All right, let's see what someone else said. I noticed the triangles look the same except for their lengths or measurements. I wonder how much of a difference there is between them. Okay, so that's a good wonder. How does it change from here to here? And is it the same as that change? And is it the same as that change? Okay. I noticed one triangle is bigger than the other, and there are angles that have different variables. Well, these aren't variables. Those are just names of the points, right? Those aren't variables. Those are names of the points. The vertex, each vertex, that's point R, that's point T, that's point S, right? I notice that there are two triangles. Okay, very good. You can see. And that they are letters that are representing the sides of the triangles. So the letters do not represent the sides. The letters represent the points at the end. And I see numbers. Good. And I think they are measurements of the triangles. They're measurements of the sides. Like this is the measure of side RT. This is the measure of side TS, and so on. I notice a big triangle and a small triangle with different numbers and letters. Thank you. Yeah, that person has a nose and two eyes. Good job. I wonder how to solve a problem like this. Okay, so there's nothing to solve here, right? There's nothing to solve here. They're just two triangles, right? But maybe this person means they wonder how this is changing from here to here. So this is what I'm trying to help you become better at. Because I don't know if you know this, but like in 3 years, you guys are going to all be adults. And so you need to start asking more adult questions. You need to be making more adult observations other than, I see triangles. The letters are black. The numbers are blue. right? We need to start making more adult or young adult type answers. That's okay. That's what I'm here. I'm not mad at you. I'm here to help you to get better at that. Next person says, what I notice about the two triangles is that they look really similar. They do look really similar, right? If I look at this and I look at this, somebody might think, this smaller one, if I enlarged it, would it fit directly on top of that one? They look really similar. Ooh, I like that word. Just pin that word. Pin that word. Okay. What I wonder is if they are the same with just different numbers. All right. Now the other person said, I noticed these triangles have 3 sides. Yes. Good job. Triangles do have 3 sides. Hence the word triangle. If I had a triangle with 4 sides, I'd be really, really, really suspicious. And they can also have degrees. Very good. Yes. These angles do have degrees, but there's no measurements. The measurements are of the sides. These are not numbers for degrees. It would have told you here, or it would have been in there if it was degrees. I'm guessing it might be a vertical angles, and one is smaller than the other. Vertical angles? What vertical angles? That there is a T and S and R on the sides, and like the right is a little and left is big. The right is little and left is big. Okay. So the one on the right is little, the one on the left is big. Okay. We're going to get there, guys. We're going to get there. The same shape, but different size. Okay. So they look exactly the same, but different sizes. How do we know that? Remember we did the hippopotamus? How do we know that these are the same shape? They're just different sizes. They're just enlarged or shrunk. How do we know that? So a couple of people have said that already. A couple of people said these are exactly the same. Somebody said they're very similar. How would we know? Maybe it's connected to the thing we've been talking about the last week. Maybe. They are the same triangles, but one is smaller. I noticed that there are 2 triangles, and one of them is smaller than the other. Because one of them is smaller and the other one is not, they have different measurements of each side. I noticed that they are 2 different triangles. They are different because they have different numbers and letters. What I noticed about the picture is that, and then they stopped. I think they are congruent shapes. Ooh, hold on. Let's time out. Congruent means what, guys? Congruent means they are exactly the same. And so if I look here and I look here, I can immediately tell they are not exactly the same, because exactly the same means all 3 angles are congruent, but we can't tell that. We don't know. They kind of look like they do, but we can't assume in that geometry. But congruent also means all 3 sides are congruent. So that and that are not congruent. That and that are not congruent. So they are not the same. So remember, congruent, they are the same size. These are not the same size. Okay, I noticed that there are triangles that have letters and numbers on all sides and peaks. Exactly, that's exactly what that is, but anything more specific? I noticed that they're the same shape, so one is longer than the other or bigger than the other. Okay, maybe the sides are longer, so if you look here, that side is longer than that side. Okay. I see letters on each angle. Yes. And numbers on the side of the shape also is a triangle. Okay. And then the next picture, very much like this picture, right? We have a small and a big. What do you notice here? They're both the same triangle, but one is smaller than the other. It is shrunk, but I think the numbers on the side change because the measurements do. Yes, that's exactly what that means. A smaller triangle should have smaller measurements, right? It's kind of like, what if you were watching the Super Bowl, right? If you don't know what the Super Bowl is, that's that big football game at the end of the year, the end of the football year, which happens in February. And then imagine after the game, they're like, all right, we're going to go to Bob now to give us the analysis on this game. Bob, what did you think about this game? Can you analyze what happened? Why, sure I can. So the team that won the game. The team that lost the game. And the winning team had more points than the losing team. All right, back to you. Did he really say anything? No. He just said some obvious stuff. Right? You got to give me more specifics. You got to tell me specifically what are you talking about. Yes, why did they score more points? Why do you think they scored more points? How come how come the other team didn't score more points? What did they do to stop them? Those are the specifics. Same thing here. Yes, we all can see the elementary school stuff. We all can see there are numbers there. We all can see they're both triangles. We all can see they have lengths. We all can see that. That's not what I'm looking for. We're in high school now. We're looking for, do you notice anything beyond the obvious? Can you be a little more specific on what you notice? Okay, that's what I'm looking for. Now, I have heard, now I'm not saying no one has said anything good. I've heard a lot of good pieces here and there. I've seen a lot of good pieces here and there. So just because I'm saying that, there are some of you who are just saying obvious stuff. You need to go a little deeper. But there are some people that have said some stuff. That these look exactly the same, but one looks bigger, one looks smaller. They look very similar to each other. Can we look at these and is something going on between these numbers? Same thing here. Is there something going on between these numbers? And can we look at these ones too? Is the same thing going on? Right? So we are hearing some people saying some keywords. Why is one triangle bigger than the other? Okay, so not the 1, 2, 3. So 4 of you answered the second question. Are you kidding me? 4 of you answered the second question. With those answers for the first question, only 4 of you answered the second question. That's really, really pathetic. Especially the quality of what I got from the first question. 7 minutes. You can only look at that and say, there's 2 triangles. Well, that took me 7 minutes. Are you serious? Look, I'm here to help you as best I can, right? I'm here to give you every chance, every opportunity to make up work, to ask for help, to understand this stuff. I'll explain it 100 times if I need to, if that's what you need. But when you come in here and you give me this kind of effort, you know, I really don't understand what you want, what you think's going to happen. You know, this is very frustrating that we come in here. Yes, this is tough. This is a tough way. We are all going through tough stuff. But when I see this level of effort, it really gets frustrating. You didn't see the second question, but you started the first question like 5 minutes in. So it's very frustrating. Yes, we all are going through bad stuff. We all don't like it like this. We all would like to be back in this stupid pandemic to be over. I get it. We all are going through some crap. But when we're in class, I expect some effort. And if you think you're just going to understand this by not doing anything, you're not going to. And if you think I'm just going to pass you by not doing anything, I'm not. If you don't want to get the free points by doing a damn warm-up where you answer 2 simple questions, I don't know what else to tell you. When you don't want to try the classwork I give you, I don't know what to tell you. When you don't want to try the problems in the homework and ask me questions when you're confused, I don't know what to tell you. You're going to go through life not understanding things and I'm afraid to ask questions. Are you freaking kidding me? Some of you in here need to like knock that kid out of yourself. Yes, I understand you're young, but you are not in elementary school anymore. And some of you need to stop acting like you are. Right? I'm babying you a lot in this class and you still aren't passing. A lot of you in here. And it's very frustrating. I give you so much time to do work. I give you so many opportunities. I beg you, can you please click on the link to do the warm-up? And you still don't. Just ignore me. And I understand you're going through crap. I understand that. We all are. But to click on a link and answer a couple of questions that takes you 7 minutes, it shouldn't even take you 7 minutes. And only 4 of you did the second question. I really don't know how I can't go over there and hold your hand for you and do the writing and move your hand so you can write on a piece of paper to turn in homework. I can't do that. You got to try. And if you don't try, you're not going to understand this. And if you don't understand this, you're not going to do well on the tests and quizzes. And if you don't do well, you're not going to pass, no matter how many times you take. I can let you take the test and quiz 100 times. But if you don't try the problems, if you don't ask questions, you're not going to understand it and you're not going to pass. And I am not going to pass you. And you're going to have to take this class again. I don't want to do that. I'm trying to make this simple for you, but you guys are making the simple impossible. We go 2 weeks with one homework assignment. Can't do it. Really? 2 weeks to do one damn homework assignment and you can't do it? And then right before report cards, oh, mister, can I do all the homework? Can I do every single thing right before? Sure, but you're not going to do well on the test and quiz doing it like that. You can turn in all the homework and classwork and warm-ups you want right before the report card. But your tests and quizzes are the majority of your grade. And if you don't do well in those, you're not going to pass this class. I told you got to do 3 things to pass this class. You got to try. That's the first thing. 3 little letters. Try. And some of you don't even know what that word means. Try means I give you a problem, you do it. Right or wrong, you do it. And then you look at the answer and you compare. That's the second thing. Learn from your mistakes. Right? You're not going to learn from your mistakes if you don't try anything. And then the last thing is ask questions. When you are stuck, you need to ask questions. So I really don't know what to say anymore with you people that don't want to try, that don't want to give me effort. It's very frustrating. Very frustrating. All right, so we have some new notes. So again, I'm going to show you how to do it in case you forgot. Go to Schoology. Go to our course, which is period 14. And you go down here to week 8. Yes, we are in week 8. 2 more weeks, another report card. So I'm going to all of a sudden magically hear these people that are interested in their grades all of a sudden. Because a lot of you are only interested in your grades when these damn report cards come out. In between report cards, who gives a damn? I'm not going to help you on tests and quizzes like I told you. So in week 8, you click on it and you're going to see notes. Now, again, you do not turn in notes. But mister, it has a due date. That means it's an assignment. Yes. Oh my gosh. Yes, I am screen sharing, but someone barely told me that my screen wasn't on. Thank you. Thank you. We've only been in here for 30 minutes. So again, you go to Schoology, go to our course, click our course, and then you go down to week 8. Click on week 8. Now, it looks like it's an assignment. It is. I have to put it in as an assignment. I have to put it in here as an assignment so that way some of you can work on it on Kami, because I know some of you like doing your homework on or your homework and your classwork and your notes on Kami. So when you click on this, if you are in Google Chrome, you will see next to view, you will see that it says open with Kami. It doesn't say it here because this is my iPad and Kami doesn't work like that on the iPad. So you can click on this, you can open with Kami and start taking notes. You can click on this and you can print it out or just open this up in a different tab. Or some of you like to take notes in your handy dandy notebook, right? And I'm going to give you a couple of minutes to either print it out, open this up in a tab, open this with Kami, however you take notes, if you even take notes. I'm hoping you guys do, but give you a couple of minutes to do that. Mister, why are you mad today? I'm not mad. It just gets frustrating when this could be the easiest class to pass and some of you are just making it impossible for yourselves. And some of you in here, you're lying to me. Mister, I want to try better. Mister, I want to. Mister, I want to learn. I'll accept your help. I'll ask more questions. All words. All words. All right, so let's go over what we were talking about. So look at these words. Look at the words right there. Similar polygons. You guys see these words right here? Right? When I zoom out, do the words change? No. What happened to the words? This is the participation part, guys. This is the part where you answer. They got smaller. Okay, now what happened to the words? They got bigger. But how do you know it's the same thing? How do you know that that's the same words that I'm zooming in and out of? How come it doesn't look different? How come it doesn't look different when I zoom in and when I zoom out? It looks exactly the same, just a different size. right? It's not getting distorted. Remember we talked about that last week with that hippo? Not everything is staying the same, but just getting bigger and smaller. And what do we mean by the same? Because a lot of you said that in the warm-up. It's the same. It's the same. But we have to get more specific by what do you mean? Like, what is the same? Okay. When two things are the same, and we'll define what the same means in a second. When two things are the same but different size, we call them similar. We call them similar. So if I draw a triangle, let me draw, not a triangle. If I draw a happy face, okay, there's my happy face. Is it the same happy face when I zoom in? Is that the same exact one I drew? Yeah, it's just bigger. There's my same happy face, but it's tiny now. It's way out there. We say when figures are the same but different sizes, they are similar. Similar polygons, similar figures, similar diagrams. So let's give a definition. And remember, we're starting a new unit. So we're starting with new definitions, new explanations, brand new stuff. So if you don't understand something, this is the exact time you should ask, because if you don't know the basic stuff, if you don't know the beginning stuff to a new lesson, then the rest of it's going to be really, really tough. Okay? So let's define, let's give a definition to what similar polygons are. Okay? So let's see, I bet you can fill out this first one without me having to tell you. Similar polygons are polygons with the same blank, but different blank. What's the same and what's different when I say similar polygons? When you have a big one, the two sizes, the two shapes are the same, but one's big and one's small. They have the same blank, but different blank. What do they have the same of? They have the same what? Same size? Were those triangles the same size in the warm-up? What do they have that's the same? Shape. Exactly. They have the same shape, but different size. There you go. You just had them backwards, right? First one is shape, second one size. So they have the same shape, they're just different sizes. And why would we want to do this? Anyone out there make those model cars, or anyone have collectibles or figures or something, and then it says made to scale? You ever hear that? Or a scale model? Right? And then if you buy these, let me see, if you buy these and you look on the cover, it should give you a scale factor. Let's see. Come on, Target. Okay, so this one isn't drawn scale, so it doesn't give you the scale, but this is drawn to scale. I'm trying to find, I know on the boxes they have them. Now I can't find it. Well, have you seen those, right? They have on the box, or it tells you that the scale's like 1 to 7, something like that. Meaning it's the same exact as the real car. It just has a 1 to 7 ratio, right? Okay, so we'll talk about what that means. That it's drawn to scale, 1 to 7, 1 to 10, 1 to 5, 1 to 2, that kind of stuff. So there are two things that need to be true for polygons to be similar. Two things. First thing, when I look here, and I'm going to draw a triangle. Look at the angles. Look at that angle. Look at that angle. Look at that angle. When I shrink it and enlarge it, do those blue angles change? And remember, an angle is determined by the sides. So if an angle to change means there's an angle and now I changed it. Okay, that's how angles change. Is the angle changing when I zoom in and out? Yes or no? Yes or no? Does the angle get bigger, smaller, or stay the same? Now, look at the actual angles. All right, this is the part where you answer me, guys, in the chat. Are the angles changing? Hello? No, they're not. They're not, because this angle, because if the angles changed, then I'd have a different shape, right? If I change this angle right here, if I change that angle, meaning here's the bottom, and then so now I'm going to change the angle to be like this, guess what? Now, since this angle changed, the shape is different. So the angles don't change. So when I zoom in and zoom out, the angles stay all the same. So polygons are similar if all corresponding angles are congruent. Okay, corresponding just means matching, right? So if I look at the two figures, and the angles are the same, that's step one. Because when you zoom in or out, the angle should not change. Because if you change an angle, then you start distorting it. You start changing the shape. So those angles stay the same. What's the only thing that changes, guys? What's the only thing that changes when I zoom in and out? Look at this triangle. What's the only thing that's changing? The size, the length, right? This right here is that long, but now when I zoom in, when I zoom out, now it's tinier. So the only thing that are changing are the side lengths, right? That's all that's changing. So what we can say is all corresponding sides are not congruent. They're not congruent. The sides change at the same rate, right? Remember, we don't want to be distorted. If I have a triangle like this and I want to double the size, I got to double this. I got to double this side. I got to double this side. I got to double that side. All of the sides have to change at the same rate. If they don't change at the same rate, then it's going to be distorted. So what's another word for rate? Where do we get rate from? We talked about this. If I double one side, I got to double all the sides. If I triple them, I got to triple all of them. That's my rate. What's that other word? Rate. That's short for something else. Rate is short for something else that we've been talking about for a week. Come on, guys. You know this. What's rate short for? We've been talking about it for a week. All right. No one wants to participate. Okay. Ratios, right? Rate is short for ratios. They're growing at the same ratio. And if you have the same ratio, two ratios that are the same are called a what? Two ratios that are equal. We've been talking about this for a week. What are two ratios that are equal called? Two ratios that are equal is called? Come on, guys. We've been talking about this for a week. If we have two ratios, two fractions equal to each other, it's called a proportion. Thank you. So all the sides are proportional. That means the ratios, they grow at the same rate. They grow at the same ratio. That's what we're doing. So the angle, so when we look at two polygons and we want to know if they are similar or not, meaning is it just zoomed in or just shrunk? These two things have to be true. All the angles have to stay the same. That means all the corresponding angles are congruent. And the sides have to be proportional. That means they grow at the same rate, right? You can even put that in parentheses. All sides grow. Oops, I can't even draw. All sides grow or shrink at the same rate or ratio, right? So that's all that means. All the angles stay the same because you don't want to change the angles. That'll change the shape. And all the sides grow or shrink at the same rate. They have the same rate just means they have the same ratio, which means they're proportional. Okay? And this ratio we're talking about, this ratio that they grow or shrink at, this ratio of corresponding sides, like if I say I double it, if I say, oh, that's a 2-to-1 ratio, that means this figure is 2 times bigger than that figure, 2 to 1. That ratio is called the scale factor. And that's exactly what we were talking about earlier. When you see on those models, those model cars, you'll see like 1 to 7 scale. That means if the car's 1 foot, that means the real car is 7 feet because it's a 1 to 7 ratio. You got to multiply by 7. Okay, everyone understanding? So we have similar figures. That means figures that are just shrunk or grown, right? They're exactly the same, but they're shrunk or grown, so they call them similar, zoomed in or zoomed out. And there are 2 things to know if they are similar. We have to see that all the angles are still the same and that all the sides grow at the same rate. They grow at the same rate. They are proportional. And this ratio, however, this ratio between the 2 figures is called the scale factor. Okay, and one last thing. If polygons are similar, then their perimeters are similar. Perimeter is just distance around the figure, right? All right, so that's all we're doing today. So, as I said, if you have any questions, please ask. Please ask. If you have any questions and you don't ask, I really don't know what to tell you. I don't know if you noticed, we've only done one small part. I don't know if you noticed how slow we go so I can go over this stuff. I do this for you guys. I go super slow so you can understand this and you can have time to ask questions. But I get no questions. I get a couple of the same people answering the questions. So if you're wondering why I get frustrated, that's why. Because there's going to be a bunch of you that fail this class that don't need to fail this class. That could have easily passed if they just did simple things like stopped me, asked questions. I mean, I should have gone through this whole thing today. I should have gone through all 3 pages today. But that would not be the best way to do this. Because I'm trying to help you all pass. I'm trying to help you all understand. We did one little box today. And guess how many questions I got? I got 0. And looking at you guys, I know you guys. I know there's at least 10 of you in here that don't understand what I'm talking about. And you didn't ask a damn question. So, I mean, I really don't know what else to say. If you have a question, please ask. I will go over it again. I will erase it. I will re-explain it. I'll show you another way. But I need you to tell me those questions. Because if I hear silence, that's telling me you all get it, which I know is not true. All right, that's it for today, guys. If you have any questions, again, let me know. There is no homework yet. I have not put up the homework yet. We're just starting to take notes. Tomorrow, we'll continue to talk about scale factor. You'll see what all this. Now, some of you may look at this and say, "Mister, I don't understand it 100%. I don't understand it 100%, but you'll get it when we start going over examples." Okay, so somebody asked me to zoom in on these parentheses. This one says all sides grow or shrink at the same rate or ratio. And then the last one is perimeter. You guys know what a perimeter is, right? That's 4th grade math, distance around the figure. So proportional just means all sides grow or shrink at the same rate, and rate just means ratio, right? And then perimeter is the distance around the figure. Those are also proportional. All right, if you don't have any questions, have a great rest of your Wednesday, and I will see you tomorrow.